Good morning, everyone. All right, today's lesson we're going to learn about number of types. Now, the vocabulary contents are natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. So, we're going to start with natural numbers, and we're going to represent it with the letter N. Now, if you notice, natural number is a set of numbers from 1, 2, 3 to infinity. There is no zero here if you notice it. So what we could say is or our natural numbers are positive numbers. They are not fractions, they are not decimals. Now, let us figure out which numbers are considered natural number. Is 0 considered a natural number? No. How about 9? Yes, 9 is considered as a natural number because it's a positive number. Negative 4, is it considered as a natural number? No, because negative 4 is negative. 12, is it considered as a natural number? Yes, 12 is considered as a natural number. Because it's a positive number, it's not a fraction, neither is a decimal. Root 2, how about root 2? Is it a natural number? No, it's not a natural number because if you find the square root of 2, you're going to get decimals or fractions. And we here, natural numbers are not decimals, they are not fractions. So let us use a circle to represent natural number and label it letter N. So what are natural numbers? Natural numbers start from 1, 2, 3 to infinity. Whole numbers. Let us use a W to represent whole numbers. Set of whole numbers consists of 0, 1, 2, 3 to infinity. Now take a look at 5, negative 7, root 4, 3 over 4, negative 1, and 0. If you notice, whole numbers are not fractions, they are not decimals, but it consists of 0, 1, 2, 3. So, is 5 a whole number? Yes, it's a whole number. How about negative 7? Do you think it's a whole number? If you look at the set again, there are no negative numbers. So, negative 7 is not a whole number because it's negative. How about root 4? Root 4, if you find the square root of root 4, it equals to 2. So yes, root 4 is a whole number because root 4 equals 2. And 0 is a whole number. Now, can you tell the difference between a whole number and a natural number? The difference between a whole number and a natural number is the whole number has 0, while the natural number has none. Only 1 to infinity, and they are positive numbers. So remember, root 4 equals 2, as also considered as a whole number. Alright, so we're going to start again. This blue circle for natural numbers 1, 2, 3 to infinity. We'll have the yellow circle for whole numbers, and which is made up of 0 and consists of natural numbers 1, 2, 3. So therefore, all natural numbers are whole numbers, but not all whole numbers are natural numbers. And why is that? 0. Next is integer. What are integers? An integer is a whole number, not a fractional number that can be positive, negative, or 0. Set of integers, let us assume is z. So we have in the set negative to infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3 to infinity. So let's take a look at these numbers and see which one or which ones are integers. Is 5 an integer? Think about it. Now take a look at pi here. What is pi made up of? Pi is made up of 3.14 approximately. So don't get confused here. And 8x is a variable here. We don't know what's x. So 5 is considered as an integer because it's a positive number. How about negative 7? Yes, it's a negative number. It's considered. 8x? No, because we're not sure what x is made up of. It could be fraction, it could be decimal, it could be anything. So we are not sure. So we cannot consider it as an integer. Pi, remember, it's 3.14. It's a fraction, so it cannot be considered. How about 7? Yes, 7 is considered because it's a positive number. It's a whole number. It's not a fraction. It's not a decimal. Negative 32 over 4. Let's break it down. What do you think will be the answer? It will be negative 8. And 0 is an integer. So remember, negative 32 over 4, if you break it down, it's going to give you negative 8. And negative 8 is a negative whole number, which is considered as an integer. So that's why it's considered as an integer, negative 32 over 4. Okay, so remember pi is a fraction, can be considered. So let's do a quick summary again. The natural number n is made up of 1, 2, 3 to infinity. The whole number is made up of 0, then into the natural number 1, 2, 3. And now the integer. The integer will represent with the letter z. It is made up of negative number, 0, which is considered as a whole number, and positive number, which is considered as a natural number. Now, rational numbers. Rational numbers is a number that can be expressed as a quotient or fraction of two integers. Consider p over q. Now let p be the numerator as long as it's not 0, and q has the denominator as long as it's not 0. P equals to 2, 3, negative 5. Since q may be equal to 1, every integer is a rational number. Can be considered as a whole number. Did you know that? 3 over 1 can be considered as 3. Negative 5 over 1 can be considered as negative 5. So all whole numbers, once you make its denominator 1, it can be a fraction. Let's represent rational number with the letter q. Set of rational numbers q equals x to x, which we consider as a ratio, and it can be converted to a fraction, p over q, where p and q are integer numbers, and q is not considered 0. So 1, 5 over 25, 0.33, negative 1 over 7, root 2, and pi. Which one or which ones are rational numbers? One is considered. How about 5 and 25? Remember, they are fractions and they're made up of integers, right? Yes, 0.33. It can be converted to fraction as 1 over 3. 1 is an integer, 3 is an integer. So do you think 0.33 is a rational number? Yes, it is. Negative 1 over 7. Do you think it's a rational number? Yes. Root 2. If you convert this into, if you simplify root 2, you're going to have a complex fraction. I don't think it's part of it. It should not be part of rational because it's a complex fraction. And also pi, if you convert it to numbers, it's going to be in complex decimals or even fractions too. Now, let's do the summary. Natural number made up of 1, 2, 3 to infinity. Whole number is made up of 0, 1, 2, 3. Integers are made up of negative numbers, 0, and positive numbers. Now, rational numbers are made up of simple fractions and decimals. And they are also made up of whole numbers if the numerator is over 1, 0, and positive numbers too. Alright, irrational numbers. This type of numbers can be in form of fractions, but when converted to decimals, they are not terminating or occurring decimals. Example, pi. If you want to find the value of pi, it's 22 over 7. Yeah, it looks simple, right? But converted to decimal, it's 3.1415926. It's not. It doesn't have a pattern and is never ending. It's kind of like a complex decimal. There is no pattern, no ending. Same as others like root 2. If you convert it, it has no ending as well and no pattern at all. So these are considered irrational numbers. So let us identify the irrational numbers given. Pi, root 2, root 3, root 4. So look at pi. Pi is considered as a irrational number because when you convert it to decimal, it's never ending and has no pattern. Same as root 2. Root 3 too. How about root 4? Root 4, if you simplify it, it's not a rational number. It's not an irrational number at all. If you simplify it, it equals to 2. Irrational number. So let us do our summary. Natural numbers 1, 2, 3 to infinity, positive numbers. Whole numbers 0, 1, 2, 3 to infinity. Integers, negative numbers 1, negative 3, negative 2, also 0 and positive numbers. Rational numbers, they are made of decimals, which are terminating or occurring decimals that have patterns, and fractions, which are not complex. They have integers as numerators and denominators also integers. A negative 1 over 7. Irrational numbers, on the other hand, is a different ballgame. It's separate from this other group rational and is made up of pi, root 2, root 3, root 5, and other complex numbers. Everything is all considered real numbers. So real numbers is divided into two categories, rational numbers and irrational numbers. So that is the story of real numbers. Real numbers are the numbers that include both rational and irrational numbers. Okay, so that's the end of this. I hope to see you next time in the next lesson. So I have a question for everybody. Real numbers is divided into how many categories? Please write in the comments given below. Bye. See you soon.